Oh, okay.
You know,
Right. Yeah.
that kind of thing.
Yeah.
So,
Yeah.
Qualcomm Hall should be
Qualcomm Hall is open.
completely open, no login, no password.
Yes, that's what you want. You want the Qualcomm Hall. We're looking okay. I'm gonna check on doing her. Well, I should do it. Okay.
So you're officially out.
Okay.
It's
Yes, it's not quite as off as we thought it was.
Yeah. The door problem alarm was disabled, but when we shut the door, it is now.
Must be a temporary thing.
It's temporary. Yes. I like that this is working. All right, we'll get started in like 7 minutes.
6 minutes. Yeah, that door has an alarm on it.
It's going to this Python meetup and the alarms Yeah, I know. Yeah.
Oh, Nathan. Only the other one.
We had it on alarm, but we shut it.
We broke the no alarm.
I see. The contact with security.
Yeah.
Yeah.
Luckily, I'm getting what it is.
Yeah.
Yeah, we have all these other. That's what it is. The artist scholar.
It's nice to chat.
Yeah.
I mean, I think the proper one like restarted when we accidentally
Yeah, exactly. So, on the other device, that.
Right. Should be okay.
All right. Okay. Oh, I'm going to switch the video.
Not that I'm important.
It's the, you turn on the break. the screen on?
Yeah, I'm good. Well, the screen will turn on once somebody plugs in. It's on.
Oh, okay.
Well, camera should be on. Should be. Why is this thing not working? My IP address changed? Oh. Now I need you. Oh, there it is. Okay. Yeah, let's go. Oh, awesome.
All right. Small technical difficulties, but I think we're in good shape now, actually. So hopefully everything's good. Welcome to San Diego Python. You're in the right place if that's what you're here for. If you're here for something else, well, you're in the wrong place, and I'm sorry. I want to thank Qualcomm for having us and the engineering development team, and specifically Drew and Urigon, who helped smooth that process and let people into the hall and all the stuff that comes with hosting the meetup. So that's really awesome. I also want to thank my co-organizer, Jeremy, who helps wrangle all the speakers so we have good talks and everything like that. Yeah, just lots of stuff goes into even just having a small meetup. So I want to thank everybody for helping out. Welcome to San Diego Python. I guess I'll just go through a couple announcements before we get right down to speakers. Couple announcements. There's a virtual Saturday meetup. It meets on Discord. You can check the meetup page on also the San Diego Python website, sandiegopython.org. You can get all the information about it. You can get a link to the Discord. It meets virtually on Saturdays at 10 a.m. It's a little bit different from this one. There's not a scheduled speaker lineup or anything like that, like there is here. It's more of a bring a project, bring a laptop, work on what you're working on, and chat with other people. Maybe you've run into a snag on your project or something like that. You can work through it with other people in the community, in the local community. We do stream the monthly meetup, this meetup. It's being streamed to YouTube, so it's on YouTube Live. Our YouTube channel is youtube.com/San Diego Python. You can remember that one, hopefully. And the Discord channel, you can get there from sandiegopython.org. Also, there's a jobs channel on there. So, if you're looking for a job, if your company has a job opening, all that kind of stuff, that's a really useful channel, to use either to post your job, because, there's only a limited number of people here, but there's hundreds of people on the meetup group. So, if you post your job there, it's going to be seen by local Python developers, which hopefully that's what you want. Or if you're looking for a job and you are a local Python developer, well, you're the people who those people are trying to connect to. So that'll work. I did want to talk about a couple events. I guess March Mingle was yesterday. That was just on my list. So hopefully y'all were able to attend that. That's like a local tech scene meetup, San Diego wide. It's a paid event. They met at Valley High down on Shelter Island yesterday. I couldn't go, unfortunately, but I actually love that meetup. That event always has a couple hundred people, yeah. And I wanted to just talk about PyCon US, which is coming up. PyCon US is in Pittsburgh this year. It's May 17th to 19th is the core talks days of the conference. There's tutorials before and sprints after. I think I got that right. So, you could go for longer, but the 3 days, those are the core days, May 17th to 19th. I also wanted to mention that you can be a speaker too. We have a great speaker lineup today, and I'm excited about it, but I need a speaker lineup every month. And when I don't fill a speaker lineup, that means I have to speak or Jeremy has to speak or something like that, which you don't want. I mean, even though our talks are okay, I would love to get talks from the community. So, I'm always looking for talks of all skill levels. You can sign up for a talk on the sandiegopython.org website. There's a link to it. And, whether you want to talk about some advanced NumPy topic, you want to talk about issues you had setting up your first Python environment, and anything in between, intermediate talks are great too. I'm always looking for all of these because, one, I love for there to be speakers at all skill levels. The people who attend the meetup are at all skill levels, so don't feel like you can't give a talk. You can give a talk. You can do it. And the last thing, I guess before I jump into speakers, I just wanted to mention our sponsor for the meetup, which is JFrog. They are a DevOps platform for continuous releases. For example, if you need a PyPI inside your company firewall, that is what their product does and more. So you can check them out at jfrog.com. And they've been fantastic sponsoring the meetup. They literally sent us swag, which I am out of right now, but they sent me swag right before our March 2020 meetup, which I never handed out until I started mailing it to people. But, you know, we never had a March 2020 meetup for another year and a half or so. But yeah, they sent me like swag to hand out at my meetup, but that didn't happen. Anyway, without further ado, I think, oh, you know what? I did have one thing. Drew, you had a question that you posed to your internal Python group, and you wanted to pose it to this meetup. Do you want to do that real quick before we jump into speakers?
Sure.
Let's hear it. And I'll repeat it for the everything.
So I work with people who are new to Python not infrequently, and it's always good to be able to recommend tools like IDEs. I think everybody should use whatever editor or IDE works best for them because of individual preferences. But I was kind of wondering about it. PyCharm had been a popular one in recent years. Lots of folks using that. But VS Code has been kind of a new thing that's had a lot of popularity. And I was kind of curious, are people starting to move on yet from PyCharm to VS Code? So informal poll or something in terms of what IDEs people use, or are people moving, have people moved on yet or not?
Okay.
Just trying to see what the trend is in the community.
Cool. So Drew's question is about what IDE people are using, especially new developers, but even developers across all skill levels. He talked about PyCharm, he talked about VS Code, or something else. And so we're going to do a little informal poll. Who here uses PyCharm like on the daily or, you know, as their regular editor? Couple people. Who uses VS Code as their regular editor? Slightly, I would say like 4 times as many people.
Those used to use PyCharm.
I used to use PyCharm and now I use VS Code. I fall into that group. Who uses something else? What do you use, Hobson? Sublime. Eclipse. Anybody else want to say? Jupyter. All right. So we got a kind of a range of stuff. So I would say still quite a few users of PyCharm, VS Code, kind of eating the lunch a little bit, and then a smattering of other stuff.
Thank you very much.
Yeah, no problem. Cool. That's our informal poll. Without further ado, our first speaker is Vishbot, who's going to talk to us about RWKV, the successor of Transformers. Vish? Oh, Vish is letting somebody in.
I don't think he was prepared for tonight. So
Oh,
yeah.
well, that's why you're the backup, Hobson. I promoted you to full speaker, but you know, now I mean we can go to. I mean, are you ready? Do you want to go, Hobson? We don't have to go to you.
I'm as ready as possible.
Okay. Hobson is going to take Vish's spot, and I'll talk to Vish when he's back, just to see if he still wants to talk tonight. But Hobson is going to talk to us about personal knowledge management with Knowt, K-N-O-W-T.
K-N-O-W-T.
Yeah, all right. I wrote it down correctly. All right. So this is the mic for the online stuff. This is the mic to the room, and then hopefully this thing just the magic happens. You know, like. It should pop up, hopefully, on the projector. That looks like something's happening.
Yeah, we're good.
Looks, the res might be weird, but.
Okay, so today we're going to talk about Knowt, a package that was originally called Vector Search. Ethan put together, for his project for Tangible AI, he put together a package that would allow you to search semantically and also with just keyword search on n-grams of your own personal documents. I did a demo 3 months ago at the Python user group of that tool after I messed it up from Ethan's presentation the prior month. And where we showed how you could ask questions in it, and we actually, and we used an LLM with that over the network going to OpenRouter in order to answer questions about your own documents, and that way you can know that it's factually consistent with your own documents. So that's a big issue with LLMs. When you ask them a question, you can't be sure that it's going to answer in the way that you would like. And so we asked it, what's the healthiest protein? And it said raw meat. And of course, we all laughed and giggled about that, but that's actually the truth in the world of the documents that we gave it to answer around those questions. And you couldn't possibly get, it would take a lot of more complicated things to make ChatGPT or some other large language model do that kind of thing. So that technology is called RAG, Retrieval Augmented Text Generation. First, let's talk a bit about ChatGPT. That's called an LLM. What does LLM stand for? Anyone? Great. What does a language model do? Great. Awesome. I guess I kind of helped you cheat with this diagram here. But you can see that on the left-hand side, if you start out with the sentence with the prompt LLMs, then it gets to choose between the next possible word. This is called a Markov chain, where we've been doing this stuff for decades. And so if you had the words, what I've diagrammed here is out of natural language processing in action. It's a diagram about what's called beam search. So it's one of the possible ways you can generate that next token using a large language model. And so there's the three main approaches that we use: sampling, and greedy search, and then this one is beam search, which is one of the better approaches. So you can just pick the greedy search would be choosing, in this case, you would choose the word can, LLMs can, because it has the highest probability of 0.15. And then after that, you would choose the next highest one, which would be generate. So you'd say your sentence would start LLMs can generate, and you'd go on from there. Obviously, there's an explosive level of complexity as you go deeper and deeper into your phrase that you're trying to generate. So greedy search is the most efficient. Of course, you only have to make one decision. You can corrupt it a little bit by adding some random noise, and that's called temperature. So if you're on ChatGPT, you can dial up and down the temperature to make it choose a less probable word. So it's greedy with a bit of randomness in it, and you can dial up that randomness with temperature. Then beam search takes that a step further, because as you can see in this particular diagram, even though can is the most probable word for this particular training set that was fed into it, R is the least probable word, but it leads to a more probable phrase overall if you go from R then to statistical, where there's 38 plus 12, which gives you 40% probability on that particular choice in this tree. So that's called beam search. When you step forward a few steps and you keep track of a few beams, they're called, or paths in the tree before you make your decision on what your next word is going to be. And then you can add in another feature of algorithms called receding horizon, where you let that horizon, or that depth that you're exploring, proceed with you through the phrase. And you would need to do that if you're trying to generate a paragraph or a book or some, they now can handle like thousands of tokens in your output. And so if you're trying to generate something very long, you're going to want to limit it, the amount of beam searches you do, both the depth and the breadth that you do, in order to come up with something reasonable. I don't know. Nobody knows exactly the algorithm that ChatGPT uses or any of the proprietary models, but the open source models use beam search, like Llama 2 and all the other big boys. Anything else? Okay, so that's large language models and how they choose the next word. As you can see here, there's no goal. Normally, with an AI, when you actually have something trying to make intelligent decisions, you have a goal in mind. And so you would actually try to maximize some conversational goal that you have for the conversation. But that's not happening here. The goal is encompassed in the training set, and the weights applied to each of the labeled training examples that are fed to it, including the reinforcement learning, human in the loop reinforcement learning HLRF, it's called, which was one of the big innovations ChatGPT came up with in OpenAI, in order to guide the conversation, seemingly guide it into more reasonable areas. But all it's doing is sort of overemphasizing parts of the training set and others, and de-emphasizing others. If you want to talk to Vish, I don't know if you have a presentation available. You run the agenda. I don't know if you know, but if you want to talk to Vish after this, he's got some really good insights into some papers he's read recently about basically an fMRI on neural networks like large language models. So you can tell why they're saying what they're saying, what rates caused it to generate one word versus another, and you can even see things like the network light up in patterns representative of a happy statement or a lying statement or dishonest statement. And so it has a concept of those. But as you can see, if you're looking at these graphs, and even though, anyway, I won't get into it. It's a discussion Vish and I have been having ad infinitum on whether it actually knows that it's being dishonest when it lights up and tells you, oh, I don't know how to make a nuclear bomb, sorry. But it does light up with that dishonest concept because it's been told to say something contrary to its training set by another training set, which is this HLRF and the guardrails that have been put in place. But anyway, I'm getting far afield. So we're going to talk about RAGs. Does anybody know what RAG stands for? R-A-G.
Augmented generation.
Good job. What's retrieval? Somebody else.
Response to a query. Retrieving the right chunks from a set of.
Yeah, I said somebody else, Vish. You're an expert. Experts don't get an answer.
Your own local data set.
Retrieval is from the word information retrieval. Does that make it any easier? You're kind of right, Jeremy. Sorry? Yeah, so exactly. You're explaining the entire term, RAG. That's exactly what you end up doing. Information retrieval is just search. So when you go to a search engine, the old search engines, before they inserted a bunch of generation, that's the retrieval part. And so retrieval augmented generation is a retrieval augmented large language model, which is do search first, take all the text that you get out of that search, plug it into a large language model as part of your prompt, and say, hey, here's the context, here's some stuff that I retrieved, talk about that, don't talk about something else. So that's what we did, that's what I did with Ethan's vector search. So he implemented retrieval very smartly after progressing through all the normal ways like TF-IDF vectors, sorry, won't go into that, but basically normal keyword search, basically, and then proceeded into semantic search, which uses language models to be more, find more semantically relevant documents than just the spelling of the words being correct in the documents that you find. Okay, so let's play with this package called Knowt. I can get back over here. And so Knowt is on GitLab at Tangible AI Community/Knowt. I'll browse to it just so you know where it is and what it looks like, so you know you're in the right place. And then I've got it, of course, installed and running here on my laptop. And so what I've done relative to the previous month's talk, lightning talk, and I realize I've gone long already, but I'm almost done. So you can pip install this thing called Knowt, and it will give you two classes, two main files that you want to work with. I've taken the vector search, I think that's what it was called, or search engine.py, and turned it into this package called search, which has a thing called vector DB. you instantiate a DB and you give it a corpus. So this can be any directory in your Knowt data directory containing any kind of text files. Right now it's just designed to work with TXT and MD files. And then you can tell it which encoder you want to use for semantic search. So Ethan had used BERT, but there are several others that you might want to use, and so those are all available to you. So you create your database of those documents, and then you can search it. So you can say df.search. I did HPR as hacker. Anybody know what that stands for? It's a great podcast that Juan and I enjoy. Do you know what HPR stands for, Juan?
Hacker Public Radio.
You got it. It's probably my favorite podcast out there. It's the only place you're going to get the honest truth from real people in the real world, hacking really complex things. A lot of people from Ireland and Europe are involved. Very few people at startups with something to sell. Anyway, let's see. We're in Hacker Public Radio, so we're going to ask something. I noticed one of the very first episodes in Hacker Public Radio was about, it had this word HACON in it. Now, HACON is a word that doesn't exist in the BERT vocabulary, so it has no idea what that is. This is the ugly search that just returns an actual data frame with the top 10 search results, gives you their relevance. I need to do, so I think the search pretty will give you it'll print that out in a slightly, maybe I need to print it a little better. Seems like I have added some new stuff to the display. But anyway, the number 10, which is the worst result, number 1, the best result, only got 50% accuracy, and it talks about hay fever. And so it's because it doesn't know HACON, it's not going to do a very good job. But it turns out if you look further down the list is HACON. There's only one mention of the word in 40,000 sentences of all the show notes for Hacker Public Radio. There was only one mention of the word HACON, and it was this second episode in the entire list. So if you really want to find it, you would probably use a keyword search or a hybrid search to find it reliably. But there's also, I happen to know that if you set it to only searching for individual sentences instead of pairs of sentences, it defaults to. So what I've done is I've created a rolling window of that semantic similarity of the phrases in the document. If you sharpen it up a little bit, in, what is it? No. Search Pretty doesn't have it, I bet. Yeah, and sentences. Okay, cool. I hadn't forgotten it. So let's go back to the original unpretty search. A little bit more control. And you set it to 1. So it sharpens it up. So it doesn't look for the meaning spread across 2 sentences. And I did it in a very ugly way. I didn't do the BERT embedding all over again on pairs of sentences. Instead, I just averaged the BERT embedding. Does anybody know what an embedding is? You're allowed to answer. Anybody else? Go ahead, anybody.
String of numbers that represent some context or text.
Yeah, they represent the meaning of the text. Yeah, I won't go too much into that. That's basically all it is. It's just a more meaningful representation as opposed to, and they're a denser vector, so like 384 for BERT or 100 for the smallest spacey vector. And they contain nothing but floating point values ranging typically between -3 and 3, but it's just normally it looks like noise, a big random vector. And then, a keyword search would also do that same thing, and would still do dot products, as Ethan showed 4 months ago, but it would do it on discrete zeros or ones or twos that are counting up the occurrence or non-occurrence of zeros for non-occurrences of words in your vocabulary. And there'll be tens of thousands, even a million dimensional vectors with very sparse. So dense, meaningful representations of meaning, that's what an embedding vector is. It's a vector space. You could consider, TF-IDF, a keyword search would use the same architecture, same math is done for keyword search, but this just does it better, more meaningfully. Sorry, so let's see if this does it, see if it actually does it more meaningfully. Let's look at just the sentences, so we don't have to, and you're gonna look at the bottom of the list rather than the top, because this is sorted in increasing, oh no, sentence, maybe, or text. I don't know what it's called, there we go. Okay, so it's the second highest ranked one now, Hacker Public Radio, episode number 3. The loss audio from Haycon. Anyway, so you can use that now to prompt a large language model to tell you about. So let's create a RAG. I think this will work. I gotta import it first. I don't have to tell it which corpus because it defaults to that Hacker Public Radio corpus. I've also got my personal notes in there. So that's the main thing. That's what this talk is all about, personal knowledge management. It's going to do all the generation locally, and that's why it's taking so long to load right now. It's loading a large language model, a very small large language models, 1,000 times smaller than ChatGPT. But you can see that you can get really good results with that if you use a RAG. So let's do RAG and ask. So this is a question that obviously worked before. I'm going to let it do 2 sentences rather than 1 for that rolling window. And I could adjust down the minimum relevance. As you can see, this is all very hacky right now. I'm still experimenting with it. There's a really good package associated with Llama Index. Is a really good package for implementing RAGs. While this is running, because it's a large language model, it takes a little bit of time. It's going to generate a few tokens. Hopefully this is one of my better examples. But it should be able to describe some of the stuff that happened at the Haycon. Unfortunately, it's going to only find a couple sentences at a time, and I need to come up with a better way of aggregating the sentences that are about a topic, because this word Haycon and that topic was only in the very title of it, and so it's very unlikely to find much information about the conference except in the very second sentence in that article. Yes, Jeremy.
Settings and how they're different from a hash value of a word or something?
Well, a hash value is completely meaningless. In fact, it's designed to be random. It's designed for you to, and it's also discrete. It matches a discrete bit of text exactly. So that's essentially like a token, and you're just tokenizing the entire document as one token and saying, hey, if you say exactly this, then I know exactly what to say in response. That's not at all something you can generalize from or build any kind of machine learning around. A hash is designed to do the opposite of what feature engineering is designed to do, which is come up with the most meaningful representation of the data. So let's see if we can, let's take that answer, let's put it in a variable. Let's see if I can find out what's going on here. At Haycon, Morgan, Droops, and Playboy attend one of the first unconferences. They discuss topics such as geocaching and participate in nighttime runs armed with, a nighttime run, good. No misgrammaring. Anyway, it gives you a good summary of the first couple sentences, despite the fact that I gave it context from about 8 pairs of sentences from, so I gave it search results about a lot of other stuff. And the large language model did a really good job of extracting the information that I was asking the question about and then summarizing it. So HACON is going to be right down here at the bottom. Lost HACON audio, it's probably on the 10th of November. So it gets those first two sentences. Fortunately, the second sentence in that article was a long one and said a lot of stuff that happened. And so it had a really good answer that came out of it. Any questions before I wrap it up?
Is it just doing normal vector search, or is it also doing some sort of a TF-IDF here?
I'm not doing hybrid yet. I have created the index with a hybrid trigram index, like you could get in Postgres. Oh, that's what I wanted to talk about last. So there is, has anybody seen this kind of system in the real world? People doing this kind of thing commercially, using RAG commercially? Yes, Yvonne, what, where?
Language translation system for translating chunks of data between different languages.
Great. I don't think that's using retrieval, though. That's just using generation. So those are typically just transformers, like on Google Translate or whatever. Jason?
If you go to LangChain's issues in their GitHub, if you ask a question, they have a bot that will go and look through their own stuff and give a pretty decent answer.
Very cool. So all the smart people, so LangChain was a really smart person who put that together about a year ago, or 2 years ago. And he's taken off, and I guess like 3 months into that project, a bunch of millionaires gave him a lot of money. So he builds good stuff. That's a good example. Are there any commercial, bigger examples that are more widely used by just regular people besides machine learning engineers? Google may be doing it, but they're finding it's working really poorly for them. Can you guess why? Hey, Mohammed.
Hey, Hobson.
Anyway, it's working really bad for Google because their search sucks. Their retrieval part, they're not helping their model by giving it context. They're polluting their model by giving it a bunch of advertisements. And so they have not spent their engineering hours trying to figure out how to make good search like they used to have in the old days. They've instead spent it, fine-tuned it to target you with clickbait that'll get you to click on it. And that's exactly the opposite of what you need for a RAG.
Isn't that just the results?
No, it's the first 100 results. You cannot find anything useful on Google these days. If it's about a product or a piece of software where there's a commercial option or a hacking, a cybersecurity risk option that somebody is trying to promote with AdWords. If somebody's spending AdWords on it, you're not going to find your results, except for those ones that their money is spent on. There's some alternative search engines where you can find this happening, and they're using RAG, and they're doing it successfully. Bing is another example of one that's doing it poorly because they have a bad search engine as well. Same problem. It's incentivized to do the wrong thing. Sorry, did somebody say something?
Oh, he was saying something, but I'm going to say something after.
Go on.
What?
Did you say something?
No, I just said that, but I was agreeing with what you were saying about Google. If it's not the engine that it was years ago, it was actually good.
Exactly. Fortunately, there's a lot of people are recognizing this as an opportunity, so these are the ones I'll talk about. I'll just go ahead and say it. There is Find, PHIND.com. That's really good for technical questions, Stack Overflow kind of questions, that kind of stuff. They will provide you, just as this Knowt does, they will provide you with the references for where they found the information. So you can go to the non-clickbait search results if you want to read about it yourself. They will also provide you a summary. They will also have a conversation with you about it if you want to learn something about it. So any Wikipedia article, whatever, it's just an amazing tool. Likewise for U.com, they're a little bit more broad, a little bit less technically proficient, but still really, really good using RAG. A recent one.
Complexity AI has some pretty good
Exactly. Perplexity is the third one, was on my list, and I'd almost forgotten it. Thank you. It's really good as well. It's proprietary and a little bit more close to the chest, a little bit more nimble than these other two. I haven't used it a lot. I got scared away early on because it seems like one of those things where they're going to pull the rug out from under you as soon as they get you hooked. Lastly, since Python user group, there's a new Python search engine, completely federated, completely ad-free, completely honest, and I'm looking forward to using it as my search engine for this RAG and personal assistant. You can install the plugin in your browser and help them crawl. Unfortunately, it is very early stages, and because it is free and open source and everything, it's not very well populated with a lot of stuff. But it's got a lot of information about Python because all the users know Python. It's called. I'll put it on Discord. It's MWMBL.org. Obviously nonprofit.
You mentioned quite a few websites in the past 5 minutes. Would you be able to share all of them in Discord? That's
Yeah, absolutely.
Thank you.
I'll do that. Sorry I didn't put together a more
Oh, awesome. Thank you.
shareable presentation. Any other questions?
Not a question, but comment, Hobson. So we built something similar, but I'm not sure if it's called RAG, where we connected the Python vector database with our data. Then when you are doing a search, we are getting the text, we are feeding it to ChatGPT to return the weight, and then we compare the weight with the Python database in order to return the semantic result that match our search.
That's the R in RAG. So you're doing R. You're not doing RAG yet because you're not generating then the response. You're not using. You're doing semantics.
Just retrieval.
You're doing really smart retrieval. You're doing semantic retrieval or semantic vector search. That's the thing that Ethan was working on. Now it's just trying to add the generation part to it. Yes.
Some people have these other kind of structures of data, knowledge graphs, or these other kinds of architectures to organize information. So is there, to me, it seems like in RAG, are there ways to kind of embed metadata about the context, and do they have encoders that can do that?
Oh yeah, absolutely. So that's what LangChain is really good for. So that it can help you compose. It has a lot of different tools and libraries for composing those context prompts, the prompts basically, prompt engineering. And so yeah, there's a lot of clever ways. So like I could take the title of the file, or the name of the file where a particular sentence came from. I could give it a lot more context information as part of that. And in Python, you don't really need LangChain in Python because all it does is an F string, and so where you just insert some text from one place into another. So I just like using F strings. Yes.
One more question, Austin.
Yes.
Can we do summarize for article using RAG?
Oh, absolutely. Well, it'll summarize whatever you put in. You can just, if you have an article that you want to summarize, you're probably better off just sending it straight to ChatGPT and saying summarize it. But if you said summarize, if you wanted to find something where you don't know where it is and summarize that, then you could say summarize everything you know about X, and it will go retrieve that. If it's in your database, it'll find it and it'll receive all the sentences, even if they're scattered around. So if you want to summarize something, a concept or a question that's scattered around multiple documents, that's where you want to use RAG.
That's cool.
All right, it looks like I'm out of time.
Cut you off, sorry.
Talk to Hobson after. Ooh, my paper went away. Oh no, I have it here. All right. Our next speaker tonight is Jason. Jason Koo is going to talk to us about using LangChain to build AI.
Do I even need to go up? Hobson already talked about it.
Well, Hobson said it was just F string, so I think there's probably a little bit more to it than that.
All right, I'll just show the F string then.
I'll let you get set up, but I'm going to just check that the mic is correct.
Sorry for bad mouthing LangChain.
Okay, I mean, I don't own it, but All right, well, I guess we're getting set up here. So my name is Jason Koo. I am a developer advocate over at
Neo4j, which is a graph database company. And we have been doing a lot of experimentation with large language models, RAGs, because the current, I'm far away from, I need to stay close to the microphone, otherwise no one's going to hear me. So the current, combination stack that people are doing for large language models in RAG is large language model with vector databases. Now, if anyone has actually worked with this particular combination, you will encounter a cliff very quickly, right? So vectors are really great at similarity searches, right? So it's for, if you got a whole pile of PDFs and you're like, I need to find a thing in that pile, vectors are awesome for that, right? Because it's taking your question, turning it into an embedding, and then comparing that 1,500 dimension matrix float with all the other 1,500 dimension matrix floats, and it goes, oh, these 3 docs has the thing that you need. Great, it can answer you that. If you ask a vector database, hey, how many documents do I have? Unless somebody wrote the number in one of the docs, it has no idea. It can't do basic query math. It can't do aggregations, right? So anyways, long story short, my company's been doing a lot of experimentation of taking not just vector, but vector plus graph, because graph can answer those questions. It can answer multi-hop questions, right? And I was really hoping that I literally just ran this demo all week at Microsoft Fabric. And of course, my coworkers have shut down the demo, so I can't show you this that we had running. But anyways, again, so I'm supposed to be talking about LangChain. So LangChain. LangChain, in a nutshell, is a sort of AI orchestration framework, specifically for large language models, right? So what they are trying to do is they are trying to make it as easy as possible for you to create an AI application, a large language model application, as easy as possible, and to make all the components modular so that if you want to change out your vector database, you can do it relatively painlessly. If you want to switch out your document loaders, you can do that relatively painlessly. So basically, it's, again, an abstraction framework to make this a little bit easier. Other companies in the space, Llama Index is probably, I would say, maybe the number 2. It's up there. And then also Hugging Face, of course, Hobson's favorite. So these 3, I would say, are in this space. LangChain has really skyrocketed. As Hobson mentioned, Harrison Chase was the founder. He created LangChain as an open source project. Is it still open source?
Oh, yeah.
Okay, great. So he created on the side while he was working at a different company. And yeah, in a period of 3 to 6 months, it just blew up. Like everyone gravitated to it. Everyone was like committing to it. So the whole community kind of got around this and backed this up. So in a short period, he got a huge investment, and LangChain is still, I think, probably at the top of people's go-to tool to try to orchestrate this stuff, right? Okay, so that's history of LangChain in 15 seconds. Okay, so I'm not going to go and show how to, I'll just go through some code. Since somebody had mentioned, was it Drew, that you're asking us about like IDEs? So, okay, so I got a new IDE for you to try out called Cursor, which basically runs like Visual Studio Code. Like everything, all the hotkeys, everything is very similar. The only difference is they really want you to use this command K function, which is basically to ask an LLM, hey, build me some code, right? So I can ask it like, hey, build me, let's see if I can type right. Build me, I don't know why I'm starting it that way. Build me an application or a LangChain application that loads Wikipedia pages and loads it into a Neo4j vector store. All right, I haven't tried this prompt yet. I'd be surprised if it gave me something actually meaningful. But I've tried using this tool on some other projects, and this actually was far better than any other LLM tool I've tried before. Right, like was it Prompt Engineer or AI Engineer? Those always kind of fell flat, but this one, I was like, this is actually half decent. let's see here. So it's streaming, so you can watch it go line by line and build you your code. That way, if it starts really generating terrible code early on, you can kill the stream and be like, okay, stop using my tokens. So actually, their pricing is actually interesting. So they openly say they're using OpenAI, but you can't give them your OpenAI key. You have to pay them for what, the access from them. So even if you've got like $1 million in your OpenAI account, you got to pay again to use this. So that's one thing I thought.
Who was that?
Cursor. So let's see if I can find their site for you. Cursor AI? Cursor, the AI first code editor. Yes. So if you're using Visual Studio Code, you have a bunch of plugins, right? That does like Copilot or Cody or Codium. They're used to that workflow. So all they did was take Visual Studio Code, but the first thing you're going to do is ask the LLM instead of ask a plugin. So if you've got time, this has so far been the best tool I've tried that's tried this, but it's, could still use a little work. Anyways, okay, so back to LangChain. Okay, let me just take a look at this code. Neo4j vector store. So it reads fine, except nowhere in here does it actually call Neo4j's vector functions that I know exist to actually take the documents and put it up as a chunk. Okay, so looks nice, but I'm pretty sure this would not work. Okay, so let me jump to code that I know does work. Okay, so this.
Give it a smaller prompt, like instead of giving it just wide prompt, ask it to build more modular.
Yeah, start in chunks. Actually, yeah, so that does work. Right? So start with like, build me a fast API app that has this function, and then go into the function, and then, yeah. So that would probably work better than trying to start with.
That's what I learned from the other AI program.
Okay, yes, so good suggestion. Okay, so LangChain. So they're a very fast-moving company, a lot of stuff. So when you install LangChain, you're not just doing a pip install LangChain. You're going to install probably LangChain, LangChain Core, LangChain Community, if you're using OpenAI, LangChain OpenAI, and their documentation is also behind. So there are other dependencies that you're going to have to pull in with other things that you won't know until you try it. It'll be like, oh, you also need to download TikTok. And I'm like, why didn't I just pull in with your dependency? But anyways, you will get lots of these error messages if you try this and try different tools to pack with it. Just go through them all and just install everything. And eventually it will run. So, but yeah, just don't expect like with other packages, you load the one package, you got everything. You got the one package, and that's a tip of the iceberg. More. Okay, so here's an example of importing data into a vector store. In this case, a Neo4j database. So here, this is just for Streamlit, but this is one of LangChain's components. It's a CSV loader. So all it does is you give it a path to a file, and obviously UTF-8. I don't know if anyone wants to use Blender text encoding, but you could. And then giving the CSV delimiter args, and that's it. That will take the CSV file, and it will turn it into documents or chunks. And this is meant to be used with vector databases, right? So you would take this doc, and you can put it into any other LangChain module that will accept documents, right? So Neo4j vector just has a simple from documents call. You put the docs in there. The embeddings is the LLM you're using to create the embeddings, right? So this is usually just a pointer to OpenAI in my case. So embeddings, right? OpenAI embeddings, that's it. And I abstracted it because in the future, I'm gonna try other ones. Okay, so that is it for loading. So the loading process is quite simple. So you could just build out different versions of these for different databases, different data stores. So this is nice. Retrieving the data is equally easy. So I'm going to switch over here to another app that I'm working on. This is a LangChain starter kit. So this is a little bit more verbose. So what I'm doing here is, I'm going to skip through the prompt. You can add memory, right, to a chatbot. So fortunately, LangChain makes this easy by just giving you this easy function. Create me a conversation buffer memory. You know, put some stuff in here, and then you can use this, and you add it to a chain that is intended to pass a question to your target store and to get your answer back. So you just put that like in, where is it? Chain results. Oh, of course I can't find it. Somewhere here, you put the memory. Oh, I think I took it out because I was playing around. But it usually would go somewhere here, like I think just memory. Just like that. Okay. Okay, I feel like I've already talked too fast about a lot of stuff. Why don't I stop here for questions before I talk anymore? Yes. Yep.
Can you explain more about how the graph cipher?
Okay. So the graph cipher QA chain is kind of specific to Neo4j or any graph database. So okay, I gotta stop moving. So it does text, so natural language text, and converts it to a cipher query. Cipher is the query language for Neo4j and other graph databases. You will see something similar for like text to SQL, which LangChain also has. So what this does versus like a vector embedding, right? So vector embedding, it takes your sentence, turns it into numbers, compares it against other numbers, and then gets you your information. A text to cipher call, right, turns it into that query. The query is then used to query the database. The database gives, a JSON payload back. The LLM looks at the JSON answer and goes, okay, I'm now going to read this to you like a human being instead of open bracket, open comma, blah, blah, blah. It will just basically translate that JSON payload. So that's all the graph cipher QA chain does. So what this starter kit is doing is using what I'm calling is a simple agent. So LangChain, so the chain, right, is this step of like basically chunking some data, putting it into a database, and then pulling it out. And you can have a single process. That's like one chain. Like ask a question, go blah, 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 you get an answer. That's a thing. LangChain has built a thing called agents, which allows you to take a chain, you wrap it as a tool, and then you give a whole bunch of tools to an agent. And the agent is an LLM that's like a reasoning system. So it goes like, okay, I've got all these tools, right? I got a graph tool, a vector tool, I got a Wikipedia tool, a YouTube transcript tool. And when you ask it a question, it will go, okay, I'm going to use, you asked me a video question. I'm going to use the YouTube transcript tool to try and get an answer. That chain will run, it will get an answer. The agent will look at the answer and go like, that doesn't look right. I'm going to use another tool. And then it'll ask another tool and get an answer. And then whenever it gets an answer it likes, finally, it will go, okay, human, here is the best answer that I found, which is a great concept and very promising. But every time we've tried it, or almost every time, it gets stuck in like an endless cycle. It is never happy with any answer, right? Like you read the thing like, oh, that's the answer. And go, unacceptable. And you're like, oh. And it's really hard to get the agent to stop, right? But LangChain does have other options. It has like multi-routers, and LangGraph is the newest one. And I've heard LangGraph is supposedly the most promising, but I don't have enough experience with that to tell you whether or not to use it. In this case, I went with what I call a simple agent, which is instead of it choosing a tool, getting an answer, and then waiting, is it just runs all the tools, or all the chains I give it, looks at the answers from all of it, and goes like, okay, I'm going to summarize a combination of both of these. 99% of the time, it will give you an answer that is somewhat reasonable. It is usually worded really oddly, which I can run here. Right, so here I've connected to a database of, so I had loaded some of the agenda from Developer Week that I went to a couple weeks ago. And I happen to know that one of the speakers is Sam Bradley. So I can ask, what will Sam Bradley talk about? If I'm asking vector, it's actually a very nice answer. Sam Bradley will talk about revitalizing mature and legacy products. Now, if I switch to the agent mode, which is both asking the vector and the graph that I've created from this. A very poor graph, but we'll give this a second. Based on the unstructured information, Sam Bradley will talk about blah, 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 good. Unfortunately, the structured information does not provide any additional insights on the topic of Sam Bradley's talk. Da, 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 da. So it's a good answer, right? Especially if just like a tidbit of the answer is in the tool. But you can see how just changing like which tool you're using from the same LLM can give you radically different answers, right? So anyways, okay, back to LangChain. Any questions on using LangChain? Yes?
Is it only working with the vector and graph database, or I can use it with columnar database like Redshift, Snowflake?
You can use it with just about anything. So a lot of companies have jumped into building integrations, right? So we provide two types of integrations for LangChain, but somewhere here, somewhere in their docs, LangChain integrations. More LangChain providers. Let's see. Okay, so these are different LLMs. Okay, just looking at vector stores. Wait, what was one of the companies?
Redshift or Snowflake?
Postgres.
Yes, Postgres will be in there.
Relational database.
Yeah.
Databricks here, Google. So you can see this ongoing list here that I'm scrolling down this is just vector stores.
Yeah.
Right. So retrievers, I'm guessing Redshift is in here somewhere. I could just do a LangChain. Redshift.
Redshift may not have implemented the PG vector store.
Okay. But there are many, yeah, and more companies just keep piling on into this, right? Which is why LangChain. So before, a lot of the stuff was actually LangChain just put it in their stuff, but it became so much they actually split it to LangChain Core, which is their stuff, and LangChain Community, which is why you gotta import many libraries to get it up and running at this point. All right, we'll go this way then. All right, Hobson.
I was just saying, what's in the graph database? When you saw that, when you did the Cypher example,
Yeah.
What data was in the graph database, and what kind of data works well? That sort of.
Okay. So the graph database I had, once I show you, be like, what? That's it? Like, this is all the data I put in there, which was like, I think 6 talks. So I only put in the information from Developer Week of the talks that were happening after mine. Since I was at the end of the day, there were only 6 talks after. So here I was just illustrating. So this all these yellow nodes. This is all vector, right? These are all chunked components, right? So what I was showing was when you do a chunk, right, they're unconnected. So what I did was I first connected all the chunks to a document, and then all these other parts are from the CSV import. And it's not even a very good knowledge graph creation thing. It's just literally taking each row and column and creating a relationship between the column header and the column value. But I was just showcasing how you can start to build a knowledge graph from the same data that you feed a vector store. Wait, there was a second part of that question, which was what kind of data? So data that is very interconnected. Right, so like at Microsoft Fabric, we use the Northwind data set, which was, this mock data set that Microsoft's been using for years, which is just showing like customers buying, making an order that buys a product that may be shipped to a location and has a vendor, right? Not a very complex data model, but there was enough data in there that it made, so sorry, I couldn't get this demo running, but it made a great vector versus graph demonstration, right? Because you could ask the vector, like, okay, which 2 products are most commonly bought together? Very easy graph question, but a vector can't answer that, right? And then even better was to ask, like, which products are bought together and who buys the most of those combinations? Vector with graph would give the combos, and then which customers had bought those combos and the number of orders they had done. And that was just from a relatively small data set. So we were using that to demonstrate. So that kind of, any data where you have enough connections that it becomes interesting. Right? Yeah, so more relationships better, but not so much that it's like, that becomes super noisy, right? So that's sort of the balance. Okay, sorry.
Yeah, no worries. I was was just curious, obviously you talked quite a bit about LangChain, and then you mentioned that they had raised investment. I was curious on if you use any of their paid products.
So our team has a LangSmith account, right? So we use that for observability. So LangChain has a number of products they've added to, right? So they have LangChain, which is what I showed you. They have LangServe, which takes your app and then basically puts a fast API wrapper on it, right? So that you can basically build a backend for your app, granted it being mostly like text or LLM based. And then the last one is LangSmith, right? Because they had so many people going like, we're trying to get to production. We have no idea what the app is asking back and forth with like OpenAI. So they built LangSmith, which basically tracks all the questions and answers that an LLM is giving back to an app, right? So imagine having like a console log on your on your application, but that is happening over in LangSmith, and it's giving you some aggregate data, right? And whether
So it's like New Relic, but for LangChain, or like for LLM, or it's like APM, they say, right?
Could be. I mean, I haven't used New Relic, which probably should, but yeah, it just gives you information to basically debug your app, right? Like if like people are asking these certain kinds of questions and it's totally tanking the app, why? Well, first off, you should figure out what the exact question is and what the LLM gave back as an answer, so that it will log that.
Okay, got it. So if you got 100,000 users or whatever, and some people are complaining, you want to go step in, debug, it tracks all that for you.
Yes. Yeah. Exactly.
Cool. Thank you.
Yeah. You're welcome. Okay. If there are no more questions, I will return the floor back to you.
Thank you. All right. Got my handy paper because all my devices are being used. Thanks, Jason. Our last speaker is Paul. Paul DeFusco is going to talk to us about working with Apache Sedona in Cloudera data engineering. Paul? Paul here? Said he was going to be here, and then he's not here. Well, that might be it. What? You can do one? All right. I'm going to let you set up because I wanted to double check the audio. I'm going to let you set up, and then I'm going to double check the audio. Test. It looks like the audio is okay, but it's like very much picking up a lot. You know what? I think it's okay. I'm going to let you handle it. And yeah, for some reason, like, the audio seems like it's picking up a lot, but it looks okay.
I figured we had two high-level talks, so I'm going to go back to fundamentals in Python. So this is how to build context managers. Okay, can't hear. Low. All right. All right. Let's see if we can get this directional mic a little bit more. But let's see. As far as context managers go, the context manager is a way for Python to be able to take this with keyword. Let's say, and be able to use whatever is next. So let's say maybe you've seen with open files, that kind of thing. Let's see, this is going to be. The context manager is just a way to say it's a class. In this case, we're going to build a class that this with keyword is going to be able to use. So class, I'm going to call it context manager thingy. So you don't think it's like a reserved keyword or anything like that. A context manager has three functions that are worth paying attention to: is def, dunder, init. Last time I was talking about these dunder methods. So inside this, I'm just going to have a print statement so that everybody can see what's going on. So print inside init, def, there's the enter, or dunder enter, and print inside enter and def exit. This one has a couple of arguments afterwards. We'll talk about that in just a moment. Inside, or exiting. So dunder exit. So these are the three functions. Afterwards, you can call it with context manager thingy. And let's say print running context manager thingy. There we go. And so then just running it will first initialize the class. It will run the enter method next. Next, we are inside the running context manager, and finally exiting. Okay, so these are the steps involved. Now, let's see, there's more things that can be added on, but let's say inside here, I like to get rid of these, let's see, these variables that are used. I call it value, and TB is short for traceback. And type, I would love to make this type, but that's a reserved keyword in Python. So I'll go ahead and, let's see, undo this and put that. Make some type, sure. Say, what Python enables you to do is, if anything should break inside your context manager, these are the three variables that you're going to be needing to be able to handle that traceback. So it gives you all the tools that you need. Let's see, the init is just going to initialize or make a context manager thingy object. The enter, whenever you indent over 4 spaces, now this enter is called by with. With is the, if you want to think of it as a function that's making that happen. Whenever you have whenever you finally finish your indent level, that's whenever the exit is finally called. So these things are pretty simple. There's some more things that you can add on to it though. Let's say inside this, you want to have the context manager thingy do something. So let's add in 2 things that we are going to need in here. First of all, I need to be able to manage the object inside the context manager. So inside, we've got a return self. This allows you to add on this as, I'm going to call it context manager thingy, CMT for short. So that's the object. And so inside here, we can do CMT dot whatever. We don't have anything else, so I'm going to go ahead and implement one other function inside here, def do something. And of course, I'm going to do print. I want to make this simple. Running do something. Okay, so CMT dot do something is now enabled. So let's take a look and run this. So the output, we're inside init, we're inside the enter, we're running the context manager thingy, and then we're inside running do something before we exit. So that's about it. That's context managers. Any questions? Yeah. Okay.
Not exactly a question,
Okay.
but I just want to point out, one of the things that I like about context management is that if something happens within the with block, it doesn't exit. It doesn't exit without executing what's in your exit block.
Yes. If
I mean, so your stuff is protected.
I'm going to repeat this for the people at home. Let's see. If something breaks inside your context manager, it does execute this exit. It doesn't try to break out of it or do something funny.
But if you do divide by zero within something method,
Yeah.
it'll still print the exiting.
Kind of like a trying set.
Yeah.
It'll do the
It's
file.
like the it's like the
file.
finally
Exactly.
in a trig set.
And
I haven't seen this
it's
one.
really good when you hit Control-C while you're reading a file or writing a file. It will not stop writing the file without closing the file properly. It won't leave that pointer open in RAM and exit your program, which would corrupt your file.
Or socket open or.
So
That's why you use them for files.
For the resource management, any resource database connections. Connecting the hardware. Yep. They do.
So the words that I think of whenever I think of context managers: start, stop, set up, tear down. Let's see, in, out, anything that has that nice bookend kind of relationship. It's great for context managers. So
If the thing that's the object of your with has a close method on that object, then it will be run in the default dunder exit context.
wonderful. Question, Jason.
If you had to do, put a try catch, would it be better to put it outside the with statement or put it inside?
Let's see. I've always handled it on the exit. Let's see if let's say that's a possibility. It depends on how many exceptions that you would like to try catch. Let's see. Anyway, you can put it on the outside.
Remember, it's scope, right?
Yeah.
So if the try catch will only, if it's within the width, it's only going to catch what's inside the width. So if you put it outside, it'll catch the external. Right. Width.
Yeah. It depends on the business logic that you're trying to implement.
Wanting to do.
And it also is, there's a caveat. I mean, you can only act on properties or elements within the actual class, because anything that is outside of the scope of the class, you don't know what could be the state at the time that the actual object is being removed.
Well, that object doesn't exist outside of the width state.
Yeah. The object ceases to exist after the exit statement. So.
If there is no reference.
Let's say, yes, you can do something like, let's say, CMT is equal to context manager thingy outside here, and create the object outside of this, and be able to say CMT here. And then it would exist outside of the context manager. Let's see, so that's a possibility. It's weird, but yeah, because it's it has an init. It will be there. The dunder enter and dunder exit has not been run at this or at line 16. So yes, let's say the state of which is. It's going to be whatever the state is before your dunder enter has gone into. So, anyway, thank you for your comments, and hope everybody has a good night. So, thanks.
Well, thanks, Jeremy, for handling the quick audible there. I just want to thank you for coming to San Diego Python, and thanks again to our speakers. And we are looking for speakers for next month. And thanks to Qualcomm and JFrog and everybody for coming. So, awesome. we got to be out of here by, I think 9 is when I told security, but unless you work here, then you can stay longer if you want to, but I don't know why you would. All right, have a good rest of your night. All right, I'm going to end stream here. I hope the audio was okay.